Okay, good. All right. Welcome everybody to this today, June 5th. We have a special mystery event of the AI Collective Chicago chapter. And welcome all. But let me do a quick housekeeping first before we unveil this mystery. So welcome, and this is the Agentic AI Unleashed. Thank you for naming it, and Jonathan is amazing at naming this. I love it. So and also, too, pointing out, too, we have programmers, Inc., who's here to sponsor the event, with two speakers. But first of all, too, if anybody, maybe folks are already watching online, then you know what the live stream URL is. But some of you, too, if you want to connect to it, we are on YouTube. So if you go to the AI Collective live stream page, which I actually listed out here, you can also find it underneath the live section, too, of this particular stream. And then you can watch it afterwards too, because it's being recorded as it's being live streamed. Okay, first of all, I want to take the time to thank you, the sponsors, without whom we cannot have this particular meetup. So Illinois Institute of Technology, thank you so much for letting us use this stage. And also, particularly with Nitin helping us too. Nitin is right there. Thank you, Nitin. Yeah, he's been big help in securing the space for us. So thank you very much. And then, of course, also with the food too is pizza provider Stix and Brix. And so we encourage you to visit their store too. It's very close by, right? And Jonathan went to pick that up with Jenny and Eric too. So thank you very much. And then, of course, the pizza then was paid for by programmers beyond IT. And here we have Adam in here, who's the main person coordinating. Thank you very much. Yeah. And then we also have two speakers, which I'll introduce in a second. Let me go to the next thing. Just quick thing to remind ourselves, the code of conduct, being kind to one another here. We are gathering to learn from one another. You may know something more than the other, but please share. We encourage the sharing. Everything is changing so fast, and be kind and be helpful. Also, a gentle reminder, because some of the buildings that we visit for our meetups, they require security check-in, and they very often too, they require your ID, and so when we register, we need to give them our full name. So in the future, when you register with our events, if you can give us your full name, that would be very helpful. Otherwise, we have to check your LinkedIn profile and then map it. It just would take a bit of time. So. And here too, before we forget, we have a bunch of events coming up. This coming Sunday, June 8th, is the Tech Walk, and also to your name is Crystal. I'm so sorry. How can I forget? Crystal. Yes, yeah.
Crystal has an amazing group called Tech Walk here in the city. Check it out and sign up for the Tech Walks. They move around the city, introducing you to Chicago. The walks are not strenuous, and they provide places for you to talk about technology with your peers. So please check it out this Sunday. It's going to be led by various folks from the AI Collective, including Mary and some of the other folks. Eric is in the room, and a couple other members. So please come out for that. We appreciate it.
Yeah, thank you. Okay. And then on Tuesday, June 24th, there's the future of work, and that one will be targeting companies that are hiring in our area, including companies such as McDonald's, and I think there are other organizations too. So please visit that Luma page and register for the event. It should be good. There will be short talks. And I think is that Matthew there, right? Matthew too is our helper.
If you want to talk more about this future of work, it's also going to be more of a program about what the future of work involves with AI. So talk to Matt if you want to get involved, or if you want to come, if you're interested in sponsoring. There are a lot of ways to get involved with that, but excited about that.
That's right. Thank you. Okay, and then in July 22nd, specifically on a Tuesday, we are participating in the Tech Chicago Week. If you're familiar with that, it's a week of all kinds of activities around technology, quantum computing and AI, Web3, all these things. And it's we basically a bid for this event, and it will be a bit more focusing for executive level, kind of a couple panels too around education, legal, and also healthcare too. So we do invite you to sign up for it. It will be free. It will be at Microsoft on July 22nd, but we are putting together that page and also confirming with the panelists right now. So just visit check our page when it's ready. Okay, and now is the mystery unveiled by our head of Chicago chapter, Jonathan Johnson Swiger. Thank you. Yep.
About a year and a half ago, 2 years ago, I started seeing a lot of news come out of the coasts, the Bay Area, New York, Seattle. And what we were seeing were hundreds of people gathering together to talk about AI together. And it was with the Generative AI Collective, known as the GenAI Collective. And the GenAI Collective has been around for over 2 years with around 40,000 members. It's now global. There's an event in Paris coming up soon, London, India, you name it, the cities were not in shortage. The GenAI Collective has made a bold move to move away from the name of GenAI because we're more inclusive. Many of us don't use GenAI every day. We love it. I like generating a lot of things myself. I have a lot of applications where it's incredibly useful. But many of us come from AI and machine learning backgrounds. And so this is a more broadly inclusive name for the community, but it's also more about launching the community in multiple sort of arms and spheres. We've already heard about two of these. And the first one was policy and governance. We have a group that is working actively on policy and governance, working with the White House and the US government. And so that's really important to shaping how the future is working at a policy level. So if you're interested in getting involved in AI policy, check out the AI Collective, especially our policy bridge. And they've also released as of yesterday investment arm. So for startups who are learning how to get investment, how to get seed funding, how to a process of going from startup to something gigantic, we have a bridge for that. We're also launching a inclusivity fest later this year in September. It, blanking on the name, but we're getting together in San Francisco for a large convention.
Singularity.
Thank you.
Singularity. Yeah, thank you. I was going to say yeah,
Singularity
no,
Fest.
good.
That's going to be September this year. It's where we're all going to converge in San Francisco. So we're really excited about that. It's a big moment for us to all gather together from around the world. And with that, we could talk about AI Collective all day long, but there's a better way to do that. There's a video. It's virtually cybersecurity. And I'm going to leave it over to Mary. I'm going to say thank you again to Programmers Inc. for sponsoring Illinois Institute of Technology and all other speakers. With that, thank you for listening to me and enjoy the video.
Thank you. Thank you. Wonderful. Thank you. Thank you, Jonathan. Okay, so that's the video, and I'm going to play that. Okay. Can you hear okay?
The problem we see is that there's a growing gap between how fast technology is moving. We see it every single week with AI. And then we have our ability in society to understand, to adapt, and to guide the technology and the society around us. That is the core of what AI Collective does. It is creating those forums for complex, nuanced dialogue, for understanding each other, understanding our shared humanity, being vulnerable, being authentic, relating to one another, showing that for each other, that really can only happen in person, and that's the core of what they are. The AI Collective started way back when in 2023. This was right after the launch of ChatGPT. Everyone started talking about AI, and the conversations that me and my friends were having every night in our living room, we were wondering if more people wanted to join the conversation. So I texted a few friends saying, hey, you want to come talk about what's going on in AI with us? We gathered 12 people together in a room and just had the most incredible conversation that night. So after the first event, we had 12 people. The second event, we already were up 30 people. And by the third event, we had over 250 people sign up for that third event. And going into the second year, we had more and more people reaching out to us who were visiting from New York, who were visiting from LA, visiting from Miami, saying, can I take them with me back to my city and start hosting these events? Early in 2024, we finally said, sure, to a couple of people. That's how the second chapter, the third chapter, etc., took off for the GenAI Collective. Where we are now, we have 25 chapters globally. We are in 5+ countries around the world. We have over 70,000 members as part of the community, over 100 people on the organizing team. And it's just been, again, so humbling to be part of this exponential growth for our community and for AI in general. The people who are coming to AI Collective events are the pioneers on the frontier, the people who want to be on the very bleeding edge of what is possible, playing with the new technologies as they come out the day of, and then sharing those insights with the community members around them, and realizing that this leads to collective progress in a way that simply wouldn't be possible outside a community, outside of these events. My favorite thing about who is part of the AI Collective community is it's everybody. It's really that inclusive. So yes, we have tons of founders, we have tons of investors, we have researchers, we have operators, designers, product managers, people from all different industries, all different roles coming together and bringing their own unique insights, their own unique points of view together and creating collective insight. The AI Collective has grown at a rate I would have never expected. And I've been trying to figure out why is that, right? Why are we growing so quickly? I think it's because everybody sees, one, the need to bring people together, to bring together the pioneers on the frontier with how fast this technology is moving, simply to keep up. The second is because we're all wrestling with this. It's a deeply human struggle opportunity to figure out how do I adapt to this world this technology that is moving so fast? It's a fiercely individual question, but it's also something for us all to figure out together, and this is the forum to do that. The AI Collective has 3 foundational pillars going forward. First is our events and community. We have chapters all over the world, and we're focused on hosting the best events and creating the most incredible community we can in each one of them. The flagship for all the events and community work we do is Singularity Fest, which we're hosting in San Francisco. Second, we are taking the insights that emerge from every event that we're hosting around the world, distilling them into actionable insights and recommendations, and delivering them to decision makers, whether that be policymakers, industry leaders, and the public at large, through the AI Collective Institute. And finally, our community is comprised of thousands of founders and hundreds of investors. We are also launching Collective Investments, which takes this incredible network we built from both sides and bringing together mission-aligned founders and connecting them with vision-driven funders. Going forward, we are opening more chapters. We're doing even more of these events. We're hosting a global conference, and we're doubling down in other ways. From Collective Institute to Collective Investments, we're making sure that the innovations and insights here turn into impact. So the AI Collective welcomes everybody who's fascinated with AI and believes in the transformative impact this is going to have on them and the society around them. It's as easy as checking out our website, joining the online community, and perhaps looking into attending some of our in-person events. Whether you're looking to learn, to connect, or to innovate, there's a place for you here.
Great. Oops. Okay, I think I lost my. Okay, here we go. Sorry.
The problem we see is that there's a growing gap between how fast
Yeah. Okay, I need to shrink it, but it's not shrinking. Anyway. All right, here we go. Go do it again. Okay. So thank you for watching the short clip. I hope you get a good understanding of what the organization is about. And then if you have questions too, we're here to answer you, or you can also reach out to Mothership too, so to speak. Yeah, they're actually very, very, very friendly bunch of people. So if you go to visit other cities with chapters, you're always welcome to join them as well. So yeah. So let me kind of go to the next thing. Oh, nope. Okay, so we have moved already to the presentation part. So now we have 2 presenters from Programmers Inc. And the first one is Carlos Cardoso, and he's an operations director there. And he'll be talking about, actually, no, it's spelled it wrong. It says Prodigy, right? Not Prodigy.
It doesn't have the I.
Prodigy.ai. So there's an agent platform for product ops. But let me also introduce the other speakers while kind of quick run through. Then, and after Carlos' presentation, John Gianforte will be a senior sales executive at Programmers Inc. will be talking about an agentic solution to optimize and standardize and address data set. And after that too, we probably have a little short break, and then we'll have Mo Hagigi. He's the senior director and distinguished engineer from Discover Financial Services, and also with Arunava Ron Majumdar. Some of you know him too. He's been very active in the AI meetups space too here in Chicago. So both of them, and then myself, will be moderating a quick kind of a fun panel discussion about agentic AI, during which you are all welcome to ask questions as well. We'll have a short panel for closing. And then with that, I want to thank you again all for joining our event today and supporting our organization. We promise you there will be many different types of events. As you can see, this is technical, but we're going to have also founders and startup folks matching with investors type of events, and also all kinds too, like legal profession. We have some folks here who are legal specialists too, working with AI. And other types of industries too. So if you're interested too in presenting or sponsoring us, please let us know. And again, we want to thank you again, all our sponsors, Illinois Institute of Technology, Stix and Brix Pizza, and Programmers Beyond IT, Inc. So, And then also, I wanted to have a quick word to our event volunteers. Che has always been helping. He's the quiet hero here. He's the one that helps with all the setup of the AV and live streaming. So thank you, Che. And then also to Nitin again, who's helping with all the IIT, also with other events too. And he's a very well-known student leader at IIT campus. And also to wanting to thank all of you who have stepped in to help too. So thank you to all of you. And then again, the event, if you are interested, please keep note of that and follow us too on Luma. And then if you subscribe to it, you'll get notifications. And then also just a quick kind of picture too of who are currently on the leadership team and volunteers team too. So these are all of us in here. If you have questions, reach out to any one of us here. And if you want to join us, let us know. And if you have any questions, again, the Luma link and then also the aicollective.com is where our main site is. And with that, I want to see you again in all of our future events. And now let me turn the stage to Carlos, and he will be doing the first presentation. So, thank you. Okay. Yeah.
Thank you. Hello, everyone. Just give me a moment to set up my computer. Thank you for being here today and attending to the event. Thanks, Mary. Thank you, Jonathan, for setting everything up for us. Have you seen? Didn't see my screen. Very good. Can you all read it? You need me to make the font bigger? Good. Okay. Thank you. So my name is Carlos Cardoso. I work for Programmers Inc. We're a technology services and consulting company. We've been around for 36 years in the market, and I've been with them for 25 years. So I'm not one of the founders, but I feel like I am because I've been more at the company than not being there during the existence of the company's life. And today I am here to talk to you a little bit about one of the products that we're working on. It is still in pilot mode. So we have a few clients working with us in this. But I just wanted to show you a little bit of the experience that we gathered while working with companies, some of the challenges that they face while not just implementing technology, but also figuring out the work that they have to do, control and manage process and all those kinds of things. And we understand that there's a possibility for AI to help make their work more productive and efficient without replacing people. So if you have any other questions or if you want to see more about Prodigy, just feel free to access this website and there's a lot more, but I'll be giving you an overview of the product. The goal of what we wanted to achieve with Prodigy, the name is a junction of two words, that it's product and the Prodigy thing, because it's moved by agents. So agents are very excellent and focused on the work that they're trying to do. So we have multiple agents. That's where the Prodigy comes from. And they help companies to build better quality products. So that's why we came with Prodigy. We have been working with companies that build products for all those years. And we noticed that sometimes part of the work is trying to get the idea out of their heads and into a workflow that the teams and collaboration works, right? And thinking about a software development environment where you have the idea coming from the stakeholders, coming from the clients, their feedback coming from the clients, the idea from the stakeholders, and the product owner has to manage all that information and collaborate with the teams to make sure that they work on the priority tasks. There's a lot of work involved there. One of the things that usually the product owners have to do to manage their products is create stories on boards. Probably many of you that have seen things like this. This is what we call Jira. If you haven't seen it yet, it's a Kanban board where you create stories and then you work on them till they're done, right? So there's a lot of work involved in setting up the story, getting the details right so the team can start working. The idea of our product is to help these companies streamline a little bit of this process. And we created a few agents that help with that. And if you think about this, it's nothing too revolutionary. But if you sit on a computer and have ChatGPT, you might say, well, I can do the same thing. I can build a prompt and ask ChatGPT to generate a story for me to work on and give me more details on what I have to do. Think that in scale, right? If you're doing it's a one-shot thing, that's easy. But how do you get this to work without your interaction? Excuse me, without you having to log in ChatGPT and type in, copy and paste work, and then get the output, put back it somewhere. How does ChatGPT know about your product and your company and the things that you already done in the past? So you need a database or a RAG or a vector database to handle all that information. This is the part of the hustle of using independent tools that do not cooperate or collaborate with each other to come up with a solution like this. So we created Prodigy to solve that problem. These are some of the agents. I'll be showing to you how the backlog writer works today and some of the benefits that it has to compare to doing the work manually. Okay. Just to give you an introduction here, in this case, we're working with OpenAI and Jira for the board. There are a few other integrations that we're still, some of them are ready, some of them are still under development, but there's an idea to be able to have a lot more services integrated to this platform. This is where we keep the agents that can be used, and this is where our knowledge base goes. So let's say you have PDFs that define what the project should be. I can show one to you. Some of standards in your company of how code should look like, or how would you like to write the stories so they capture all the details that your team needs to work. This is an example of a document that actually it's interesting to say that this is one of the tools that we call the self-hosted tool. We created the bootstrap of the tool and we started building it, using the tool to help build and grow it. Like some of the languages, if you're in the Institute of Technology, there are programmers here. You probably know that C, Rust, Python, some of those languages, some of the new models are developed in the language. So it's kind of an inception concept to say, but this is the same thing that we're trying to do. So we upload documents to the knowledge base that describes a little bit what we want for the product, right? So when ChatGPT or AI or any other LLM that you plug into the system needs to generate content, it knows a little bit more than just trying to come up with something that it was trained by the public data. You can add multiple types of information for now, just PDF, JSON, Excel, CSV files. And this goes into the knowledge base. It creates embeddings that are on the vector database that will be used later. Another feature that we're working on is creation of pipelines. We still don't have pipelines, but this is a way to fetch live data, not just the PDF or static data that you have in your vector database, but this will allow us to connect to external services and use live data from other sources in the generation. So the way the backlog writer works is very straightforward. I'll show you a little bit how it's configured so you understand when I run the demo how things are going. Right now we have two integrations, one with OpenAI and another integration with Jira. It's a very specific task, right, to write stories in the backlog. So here there are customizations that we can make depending on the client, the company that's using this agent. And you can provide background story, define some of the tasks that it should be working on, provide templates, how you would, this is HTML, so it's going to be hard to read, maybe with the preview. But a template that how you want your output to look like when it's generated. Some guardrails for languages to make sure that it doesn't go too much off the topic or doesn't use a specific vocabulary that you don't want to, or maybe even translations to other. And this is part of the configuration that we have for this for the agent flow. We're still working on some of those boxes, but you can see that. Can I make this bigger? No, that's not what I want. So you can see that it looks a lot like N8N I don't know if you guys already work with it, but there's a lot of integration that you have to do manually in it. And here it's all set up for us, so we don't have to worry about that. Every time you publish a new version, this is the way that we talk or get notified by external services. So for example, here, always the first box is a trigger to start the workflow, right? So in this case, we're using Jira to access a webhook on our site, on our application, to kick off this execution. So every time you publish a new version of that agent, you're going to get a URL to set up on the new version on your external service. Every time you run, it runs, you can dip into what is happening in behind the scenes. So you can see that you ran today, earlier today, and we can take a look here and see all the details for each of those boxes. What was the output? What was the input? So it helps the teams to understand what's going on, what's coming back and forth, and why it's reacting this way. Does it need any tweaks on the other end? And that kind of thing. So it's very thorough and transparent what's doing. There's zone, obviously. We're not going to click that now. So the way it works is every time a new story is created on the board, let's say the team just came out of a planning session or a meeting with the stakeholders. They said, oh, you know what? I think this is the time that we should start working on the pipelines because it's a feature that will add a lot more value to what the tool can deliver to the users. So maybe we should start working on that. And then the project manager or the project owner will go back to the board and say, okay, yeah, we need to create a story for that. But let me see how I can use the knowledge that we already have and use an AI to help me create this. So what they would do is come here. I just have a little cheat sheet over here. And we can paste that text that says, hey, I want to create a new feature to build a pipeline for Prodigy knowledge base that automatically syncs Jira user stories into the knowledge base on a scheduled basis. Okay. Just have to make sure that we're creating a story. And this combination of creating a new story and this to-do column will trigger, oops, did I not click it? Will trigger the webhook. And if you go back to Prodigy, you see that it is running now. There's a new instance executing here. And the cool thing about Jira is that if you click here, you can see it updating live. So what it's doing is looking at my ask. It's looking at my knowledge base, going through all the information that they had there. Is, oh yeah, matching the template that I created and say, oh, you know what? This is what it looks like. So I want to make sure that as a team member, I want to build a pipeline, knowledge base, blah, blah, blah. And some of the acceptance criteria that you see here, it's already some of the stuff that we already know that it's important for this company. So when we work with APIs, for example, I need authentication flows, I need data structures. I need to make sure that I focus and include API failures to make sure that we handle errors gracefully. There's a bunch of other things that are standard for this project that we know that every story that we start working on should have this level of. Great. So now, if we go back here, it's completed. And how do we work with this, right? There's just an overall idea. So in this case, instead of the BA or the PO having to sit there and write all that, we can create a standard that the LLM is always going to follow that template. So if you have multiple people with the same role creating stories, the chances that you have stories that are not structured the same or have a different wording or using a different language is eliminated with this process. So what they have to do is come here and make sure that there's nothing crazy because, you know, LLM sometimes they hallucinate and it might not be the exact information, but the more data that you put in the knowledge base, more assertive it's going to be. So the POs or BAs think this is in a good state to start working, but who's going to do what? So we have a second agent here. That's why we work on agents, because we like to give them specific jobs. So they don't get lost with too much information on the step. So we can just hook up all different kinds of events in this workflow, right? Once it's ready and we're going to go to a grooming session. So we say, well, this story is ready for grooming and want to break out this into actual tasks that the team's going to be working on. If you go to Task Builder, it's the exact same configuration. We have prompts, tasks, templates, how we want to see the output, how it should be working, what the languages should be using to create those stories. We see that there's 2 instances running here right now. The workflow looks a little different from the other one. So we can just compose these tasks the way that we need to accommodate the current customer's workflow. So it's not that the company has to adapt to the tool, but the tool adapts to how the company works. I don't think tasks date, but here we go. So just looking at this next agent, he will read the stories, try to understand what needs to be accomplished, and then we'll go back to Jira and create specific tasks for each of those items. So we have to design the interface and UI. We have to update database schema, data pipeline configuration, develop backend retrieval functions, and things like that, so it can be implemented by the team. And this is in a few minutes, we were able to create this story, this workflow, and the overall requirements for implementing a feature using Prodigy. Like I said, this is a product that is in pilot right now. It's running in a few clients. We have been collecting feedback from them. And given the feedback, I felt confident to come here and show this to you guys. It might seem that it's just focused on software development, but one of the tools that we use on our website and our products is Hotjar. And I don't know if you're familiar with Hotjar, but Hotjar is a tool that you plug on your website. It will tell you how users are navigating through your website. It creates recordings so you can replay, see where the user clicks, what areas of their website people don't actually go, areas of their website that people go the most, so you can check for performance and that kind of thing. So it gives you a lot of insight. Yeah, I would say that is Google Analytics on steroids because it has a lot more features. And one of the features that it has is called rage click. So sometimes the user on the website and things don't work and they just go crazy on the mouse. Click this button, make it work, go faster. It also detects that kind of behavior. And imagine that if we have an agent that triggers every time a user performs that kind of action on their website, and the team gets a notification that that area, giving him a link to the video that shows what the user was doing on the website and work on getting a better experience. So there's potential for a lot of more improvement on analytics, not just the development process that we can integrate here on this platform. So yeah, I guess I don't know if there's any questions or yeah, sure. Hey Mary, sorry, I don't know how do you want to conduct questions. Yeah, well, unless I have to show something else and for the question, yeah.
All right. I guess for me, I think at this point, if anybody has questions for
Yeah,
Carlos,
okay.
maybe? Yeah. Okay.
So let's go like this way. Yeah.
We don't have a mic.
We're usually using OpenAI as the
Mic.
actually using OpenAI as the LLM for the agent, or is this another integration like a tool use using OpenAI separately?
No, OpenAI is running the agent.
Okay, can you disclose which model you're using or no?
I will have to reach out to the development team. I don't know
Uh-huh.
if I can see it here. Let's see. We have some other products. John, can you reach out to Fernando and ask if he can tell? Yeah, I don't know. It's 40. I can figure it out and ask you and answer the question later.
Yeah, appreciate it.
Okay.
Anybody has a question?
Is there any evaluation step on top of agent's work?
I'm sorry.
Is there any evaluation step on top of agent's work? Like how do you evaluate?
Yeah, so during this phase, the evaluation we can do using the execution logs, right? There's a lot of information that's output there and the knowledge base. So another feature that we're building is the playground, which is not 100% yet, but the idea is that instead of just triggering your workflows through events, you can come here and chat, have a conversation with the LLM that's going to be generating the output for you and ask questions and validate if the answers make sense, given the information that you provide, given the knowledge base that it has, and then given the templates that you might provide too. Does that make sense?
Yep.
Yeah, question. You can use different LLM because the LLM I was using.
Just curious to know what edge has Prodigy have over any other homegrown intelligence within Jira, like Atlassian intelligence, because it already uses all the mentioned LLMs and if not more, and it's also within the tool, so the data is more secure. And I mean, and I feel like, of course, I'm assuming this would be a paid service, and we would also have to pay for the OpenAI services and also on this on top as an agent. So, what do you think is the edge that someone would have over using Prodigy instead of using a homegrown or an existing within the system Jira intelligence?
Yeah, well, they could use a homegrown. We're building extensions to use different kinds of LLMs. For example, you can use Anthropic. You could probably use Olama and have it running on your servers, so you save money on LLM. But eventually, this is, like I said in the beginning, is nothing new or impossible to create, but there are companies that want to focus on their product and to build, and their goal is not to build another tool to collaborate. So it is possible, but one of the things that we noticed from the feedback that we had from our clients that they could use NHN and build something like that. But it's hard to collaborate with other people. It's hard to share. It's hard to manage who's going to be using, maintaining this in the long run. So this is more like a corporate solution for companies that we can manage access during using cloud identity providers and that kind of thing, that there's more governance than just running a workflow. Okay. And knowledge.
I wanted to ask two questions. The first one being, I see that you have been integrating, this tool is available to be integrated with various platforms. I see Asana, I see ClickUp, which is pretty cool. So is that the perspective of the platform? And the second one is with respect to the tokens generated, right, by OpenAI. Is there a limit that as a company, when I'm implementing this, I can put a limit so I can reduce my API costs when I implement the solution?
Yeah. This is a demo account that I'm using right now. So before coming here today, we had to log into OpenAI and bump the allowance for using tokens. So there's a lot, all services usually they provide some kind of control that you can use on using LLM and provides you usage charts and that kind of thing, so you can make better use of the money that you're putting on the LLM. So it gets really exciting to people and they can just overuse LLM. I understand that. And but there are options that you can choose. Use a cheaper model, for example, or a home hosted model that you don't have to pay for external services. And in regards to the integrations here, these are some of the integrations that we heard from our clients that they would like to have. For example, if they get something, a notification from Hotjar, they could open an email or they could change the workflow to, instead of sending an email or open a ticket, they want to have a message on the Slack panel. So these are the kinds of things that we're adding here. We're not limited to this, but this is what we heard so far that is interesting for the companies that are testing with us and the analysis that we did with the market to make sure that we're building things that it's actually useful to most people, but we're open to feedback and we can, improve the application as well.
Thank you.
Yep.
Hi, thank you. I have two questions. So, on the knowledge base, is the knowledge base shared across different stories or different projects? And if so, how would you deal with the conflicting information? And the second would be, why do we require an agent? Like, can you walk through some of the steps that agent might be doing? Like, why is it not a single prompt, for
Yeah,
example? So, if you could highlight
sure.
some of this.
Yes, the knowledge base right now, it's limited to the data that you upload here. So if you add PDFs that have information from multiple projects, it will work. But right now, if we go to Jira and I don't know if I can show the other boards, but if you pick a different project, it will not know what's there, right? Unless you uploaded a PDF with that information. The idea of having the pipelines that you can connect multiple sources and fetch that information via MCP or via whatever we're doing to bring that context live and real time is not just the static data that's sitting on a vector database. The second question was about looking at what the agent is doing. Is that it?
Yeah.
Okay. So the first step here, I don't think there's much information. It's just we're getting a post from Jira to trigger the event. So it's just a starter step. And then when we go into more details on the other part, so we see, okay, so it's sending me a link with saying that this story was created and this board, this is the ID, and this is some of the information. So we try to map that to some of the information that we are going to be manipulating. So it's a from to kind of mapping here, so we can start working on it. And then we pass the result of this map fields to on the third step. And this is actually the one that it's going to be using the API key, talking to, oh, here we go. We're using GPT-4 Turbo. And then we just build the content that we want to send as a query. We define a few parameters, how we want the threshold for temperature, max results, and that kind of thing. Send it to the LLM, get the result back, and then we format in a way that should be posted to uh, authentication to Jira, for example. And then we know what the issue was, so we can actually go in there and update the data. This is part of the payload that goes with the request. And finally, we're done. So I think this step is mostly just changing the status on the execution to complete it.
Okay. So what you showed, it was just a single LLM call, right? And then the workflow
Yes.
is agentic.
Yeah.
Okay. Yeah.
So I think the other one might have more details, how it's doing, and if it has more LLM calls. Is just validating here. So in this case, it does a single LLM call and then loop through the results to get each of the tasks and then create a new task, goes back until you're done with the loop and then ends the execution.
Thank you.
This part is pretty straightforward. Behind the scenes, there are a lot more things going on to make sure the integrations, we handle errors, we catch all the output and output for logging and that. Thanks.
Yeah, I was curious about how someone wanting to take a user-centered design approach, would they be able to put like UX discovery research into the knowledge base, or how that might work, and possibly integrations with Figma, or making sure that you're using web components that are already in place within the design system, things like that.
Mm-hmm. It is possible. We're just not there yet. Right now, we have to create the workflow, and we're focusing on getting the data and improving the process and speeding up the process of development, helping the teams have more control over the stories and the work that they have to do. Obviously, there are opportunities for us to add in the task generation here. One of the ideas is that the test designer will probably create test scenarios and implement them in the future. If we're able to describe how we want a interface, probably just give a couple examples of other screens on the website. The design that we're following, it could be generating more, using other tools, not just LLMs, to create additional output. But right now, this is the stage that we are.
Fair enough.
Thank you.
So, a couple of questions for you. First question is right now, you're just doing one story at a time. Could you start with an epic and then create within it different stories?
Yes.
So, you start at the epic level and then you get that multiple Jira tickets come out of it and the Kanban come out of it. And
In that case, we would build something like this workflow and have a loop that will create multiple stories. Right? Just like we're creating multiple tasks for one story, we could start with an epic and then create multiple stories from that.
And then when you are creating those stories from that tasks, is a prompt defining where the story, like, are you going to have a different story for a architect? Is there a different story for a tester? Is there a different story for a UI UX designer? Or how you write the prompt will tell you where the story goes?
The way it is created right now, we can set that up in the prompts. So you could create or add a new instance of this backlog creator and set up different prompts for each of the personas that we would like it to incorporate or impersonate, let's say, to create the stories.
Any other question? Oh, no more questions? Okay. Thank you.
Great. Thank you so much.
John.
Thank you. Good job.
Oh, yeah.
Make sure you open the right one. What? Make sure you open the right one.
Well, yeah, I didn't have anyone for this too. Yeah. That's I don't have to pay for my own gas. They just upgraded too, so it's a good opportunity. Was I gonna have it all up here?
Yeah. Here, open the thing first before you. Yeah.
I don't know why I was thinking this was gonna run on a separate computer and then I was just gonna be able to spin this whole thing. like that there's function. Is that
I had, yeah.
50%?
All right, thank you. Sorry about the delay. Get back to work here. So I prepared a presentation for you tonight called Dirty Data, Done Dirt Cheap. Excuse the pun. But, you know, I want to thank everyone for being here, and I appreciate the opportunity to share a story with you tonight about a proof of concept that we just worked on. My name is John. I'm with Programmers. As you know, Carlos gave a nice introduction to the company, so I'll skip that. I'm on the business development side of the house, so I'm a lot less technical than some of you, so please bear with me tonight. I did use AI for these fancy images, but I want to tell you that no models were hurt during the production of this PowerPoint. So this story all started when a client of ours shared some frustration with us over the quality of data that they were receiving from an outside source. So they're a large property insurance company. They operate globally. That global footprint brought to light some very interesting aspects to the story. Made things just a little bit different. The files they were receiving came in different formats, different file types, and even different languages. It was more than a messy list of rows and columns. It had a lot of gaping holes and a lot of weird things, and we had a lot of challenges to tackle. But it wasn't just a formatting headache, it was a business problem. The bad data leads to mistakes, mistakes lead to lost revenue leads to frustration. It slows down every initiative. You know, whether you're launching a campaign, whether you're, you know, refarming your upgrading logistics, or just trying to get a package delivered on time. When we looked at the challenge here, we couldn't apply a traditional approach. Traditionally, cleaning data meant hours of manual review, repetitive tasks, and very inconsistent results. And I'm sure many of you have wasted way too much time trying to clean data at some point. Now, keep in mind, right, I'm a sales guy, so I'm supposed to be out playing golf or having lunch or doing something. I'm not supposed to be worrying about the actual tech that goes into this to clean this crazy list of addresses. You know, but when we were sitting there talking with the client and they asked, how can we implement some AI here? Well, it caught my attention. And I'll tell you that what happened next was really exciting. So the conversation really picked up speed. They started throwing ideas around. Everybody started getting excited. And someone said, what if we built an agent for this? And I said, an agent? Like an intern? Like, you know, somebody's going to do like, you know, all this tireless work. They might not even complain. And I said, you know, yeah, let's pursue this. So it wasn't just about the automation and the complaining. It was about building something that we could learn from, we could watch it adapt, and we could watch it evolve. And it wouldn't just be a tool, it would be a teammate. But let's be honest, it was about saving time. So what is this agentic solution? Well, in short, we were looking for a smart, autonomous system that takes the initiative to identify, clean, and standardize the data. We wanted to use generative AI and advanced analytics to detect the errors, fill the gaps, and then standardize the format, all with a minimum amount of human interaction. And even better if it was fast and accurate. Now, the journey from idea to proof of concept here, so we jumped in and we started to take this idea to a prototype. As a team, we were going to tackle this challenge and figure out how to clean up this data. We built a proof of concept. We called it our first pancake, right? It was kind of lumpy. It was burned on one side. It was able to fix some of the addresses. It mangled some of the other ones, but it kind of got stumped on anything more complex than like 123 Main Street. But the proof of concept wasn't about perfection. It was about seeing what works, what breaks, and what's worth getting fixed. Now, for the first version, we wanted to start simple but strong. Right out of the gate, we started to see progress, but it was kind of a roller coaster ride. When we designed the solution, we decided to leverage Crew AI for the agent orchestration. If you're not familiar with Crew AI, it's an open source platform, very powerful, and has a free tier. We landed on Azure AI for the language and understanding, and as a Microsoft partner, this gave us some additional benefits and an increased comfort level. For the address validation and enrichment, we started with Google Maps API just because of the ease of use, the cost, and then its popularity. We added Azure Maps during a later iteration to see if the results were better, worse, or different at all. We also used a tool called Serper API. We use that to search the web for supplemental data that we could then plug in to the system and then circle back through one of the map APIs to validate it. Finally, to tie it all together, we used a little Node.js for the front end, Python to handle the API logic. All of it was deployable via Docker.
Kept it easy and simple, and then we used some sample data sets to keep everything safe and secure. It proved to be an interesting experiment. The results, evolved and were drastically different depending on the model, and we started to layer in or combine them together for even better results. We'll talk about the workflow for a minute. So as you can see here, as we move from left to right, we would start with the incomplete or non-standard data that would be ingested into the system. And then each agent would start working on things, and they would analyze, geocode it, enrich the data, format it, and then fill out the output layer. Now, sometimes those would loop back through to add another layer of refinement, and then eventually we get to that output file. Now, during the testing, evaluating, and iterating stage, or reiterating stage as it was, this is where kind of the magic happened, or really some of the mess. So every time the agents tripped over a weird address or an API hiccup, we didn't just patch the problem. We actually asked, why did this happen? How can we catch it next time? And can the agent learn from it? So we built in a bunch of feedback loops. The agent would flag its own inconsistencies or uncertainties. It would ask for help, and then it would remember the solution for next time. It was like raising a child. If your child could process 10,000 addresses an hour and never ask for a snack. Every cycle of testing revealed some new edge cases, addresses that were missing postal codes, abbreviations from every corner of the globe. Really, it was data that looked like it went through a blender. But every cycle, our agent got a little smarter, a little faster, and a lot more resilient. By repeatedly running the address cleaner on multiple data sets, we were able to identify not just the obvious errors, but we could see subtle, complex, and rare cases, like the international address formats or an unusual abbreviation. Usually with that, a one-pass approach might miss some of that, which is why we would repeatedly feed it back. This iterative style of testing allowed us to gather the better feedback on the performance, and it highlighted both the strengths and the potential gaps. For example, after one initial round, we noticed that there were suite numbers were inconsistently formatted. So we took that and it led to a very focused adjustment, directly addressing that little quirk in the data. Another significant advancement came when we were geolocating the addresses and applying regional logic based on the local styles. But sometimes it meant adding an entirely new agent. Now, when this conversation started, we were speaking about what I thought was just one agent, but it turns out that he was a little lonely and he was only focused on one task. So he needed some friends. Our simple agent had developed into an actual agentic solution. I think when it was all said and done, we had 6 agents performing a dozen or so different tasks. Each agent was then assigned a role, a backstory, and a goal. And Carlos touched on this a little bit, but I'll go into some detail here for this specifically. When they were given a task, they used that information as their guidelines or the rules for performing the task. So we had an extraction specialist, we had an address analyst, we had an address parser, we had 2 different data formatters, and then a JSON builder. The extraction specialist, is a senior data dispatcher who will relay raw address data to the processing agents without any modifications. We told them that their backstory was that they are a reliable data handler responsible for ensuring that raw address data is delivered to the appropriate processing agents. Now, the address analyst role was to act as a data analyst. We told them that they were meticulous and that they would ensure that the address records are properly structured and complete. We then explained to them that their goal is to analyze the address data to identify the filled fields and detect the missing information. You get the idea, right? I thought we should give them all names, but like puppies, no one wanted to get too attached. Those agents would receive a line of data from the data set. They would perform their task, and they would determine if it was done correctly, and then they would pass it on to the next agent, who would then take over. That process would happen line by line through the data set, and each agent would perform their task using the information that we had given them and the tools that we provided to them. And that would continue until they reviewed and revised each line and were completely satisfied with the results. Some addresses would be updated and then passed back through all of the agents again to ensure better accuracy. True AI was able to keep them all in line, and the team of agents would work tirelessly. By the way, that last agent put everything into a new, clean, and freshly formatted output file. So every iteration had a price, literally. We had to weigh out, when is a free API good enough? When should accuracy justify the cost of a premium service? how do we keep these agents running smoothly without breaking the bank? Sometimes we'd use a free API for the bulk validation. We'd use a paid one for a tricky case. Other times we'd batch request, try to stay under the rate limits, or we might build in some smart retries just to keep things moving. For instance, when we started with Google Maps, we were able to achieve decent results, but then added Azure Maps to provide dual mapping and address validation. It seemed to get some different results there. Later, when we deployed Serper, we used it as a web scraper to enrich the data. Serper would search the web for similar addresses and supplemental information. We would then take that information and populate the fields that were left blank. Then that record would be looped back through the agent for validation and then put into the output file. Serper is a paid tool, but it's pretty inexpensive and really worked well for a test like this. Now, by validating a combination of items, we were able to work towards the end goal pretty well. Using latitude and longitude, it allowed us to pinpoint the location, and then we could search the web for information about what was actually located there. If we were expecting to see a McDonald's and the agent returned with Walgreens, it was flagged for review. And we could even then validate what type of structure it was, such as an office building, a factory, or a house. It sounds insignificant at first, it really does, but when you have a few thousand lines of addresses to sort through, and you only have to actually manually review a dozen or so, it makes a big difference, and you can notice the time savings pretty quickly. So the use of multiple APIs allowed for us to have a much more comprehensive test and much better results. We tested several different scenarios for both performance accuracy and speed. There were trade-offs for each. It made it for an interesting case of the different combinations. But ultimately, it prompted the conversation about what do we want to sacrifice? Do we want to sacrifice accuracy or speed? When we started layering the services together, we did see better results. Some were more accurate, but then we did notice that the speed was negatively impacted. So the payoff here was evolution, not perfection. After dozens of iterations, our agents weren't perfect, but they were really powerful. They could handle the messy global addresses. They could switch or combine APIs on the fly. And it would free the client's team up to focus on the real problems, not just the data janitorial work. Now, the biggest lesson we learned here is that it's not about nailing it on the first try. It's about building the system or the team that gets better with refinement and experience. We were out to solve a real business problem here. So, this particular example, it was for a use case in insurance, but it applies to all different verticals and countless uses. It could be a retail client, it could be a healthcare provider, it could be just a marketing initiative. The use cases are unimaginable, and I'm sure if you use your imagination, you could think of a dozen right now off the top of your head. But most importantly, we weren't doing this just to say, hey, we're using AI, right? AI was actually the proper solution for this problem. We ended up with more accuracy. We removed the factors of human error or oversight. It was faster. It took a task that no one wanted to do, and it did it over and over and over again. The agents don't get bored, and they always perform at 100%. So this was all great information, but if we look at the actual results, you can see here that when we ran it through, and I show 3 different examples here. So the first column is the Google Maps plus the AI. The second column uses Google Maps, AI, and the Serper tool. And then the third is just Azure Maps with AI and the Serper tool. So we noticed that, like I said, the accuracy varied a little bit with the different tools. We ended up with the best results coming from Google Maps with AI and the Serper tool implemented. There we were able to see an overall accuracy rate of 88%, and the locations marked for manual review were only 12%, and then 17% of them had some sort of formatting issue. Usually it was a foreign character or some sort of an abbreviation that they just couldn't wrangle. Go ahead. So here, if we look at, this is one of the sample data sets, or this was a portion, I should say, a screen snippet of the sample data set, but it shows here those reflective numbers here. So you'd have your input column, your output column, and as it was filling in that information, it would tally up the percentages of accuracy. You can notice there on the bottom that the flag for output file is in a foreign language, and it was just those foreign characters that would flag that, so for manual review. As I said, an 88% of overall accuracy, we were very happy with that for a proof of concept. We felt like with some fine tuning, we could push that up into the high 90s. Didn't feel it was necessary for the project. We felt like at 88%, we could confidently say that we could perform for them. And that's how we left it with them. So like I said, 88%, Of that, 79% of those locations were improved, and 93% of the missing fields were actually populated. Go ahead. So some of the things that we learned, I'm glad I was able to share them with you. But if you're building agents, or really if you're building anything at all like this, the advice that we can share with you tonight is, don't fear the mess. You have to embrace it. Don't expect perfection. Try to iterate towards it. And when it doesn't work, remember that these setbacks are just steps in your adventure. And when you get stuck, stand back and let the agent take over. I want to thank everyone. I appreciate being here tonight. Thank you. Thank you, the AI Collective. Can I answer any questions for anyone? Sure.
Okay, so in terms of the sample size, I saw that there are 85 different addresses. Really cool project, by the way.
Yeah,
It is a really good use case. Did you use a bigger sample size, or was that just the?
No, we did a much bigger sample size.
Okay.
So the sample size that was there in the screenshot was 85.
Right.
We scaled it down. We took portions of different address sets and used them there just to make it run quicker every time.
Sure.
But we tested a couple thousand addresses at a time with some of ours.
Do you happen to know the numbers for maybe like a recall instead of accuracy? Because I think the initial use case was to fix those issues with the addresses rather than just validate, right? So do you have any numbers on those as well?
I don't, unfortunately. I could get that for you and forward it over to you. If we want to connect after, I would love to share that with you. Yeah.
Yeah.
No, I mean, as far as, I really don't, I wouldn't even want to venture a guess just yet.
Gotcha. All right. Thank you so much.
Of course. Thank you.
Thank you. Thank you for the presentation and sharing this build with us. I was curious if you could share what was the final costs for running this project?
Well, you know what? I'm not comfortable sharing the
I was
cost.
curious. Okay. Can you share like
it was
a range?
It was very reasonable. I'll leave it at that. I mean, what's it? Yeah, done dirt cheap. I mean,
that's why I asked.
Yeah, no, I mean, this proof of concept had with everything involved, we were well under $10,000.
Very good. Thank you.
Yeah. Anyone else? Come on, somebody else has a question for me. There we go. What's that? I hope so.
Hi. You talked about the feedback loop in the agent system. Can you talk a little bit more about that? Like, what does that feedback correction loop looks like, and how did you go about evaluating such system, like on the LLM side?
So the feedback loop, there was a couple different feedback loop scenarios, but the main one at the very beginning there was if they weren't able to decipher the information or find the right information, then we would have to tweak that prompt so that they would either look in different places, allow less positive results of kind of allow a little more leniency on where they were looking and what they were looking at. And then it would, of course, after we reprompted, then we would just start running it again.
Okay. So was that a manual process of going through that examples?
Reprompting it a lot of times was a manual process.
Okay.
Sometimes we would, see what the results looked like, kind of look at some of the search history. There's a lot of tools that we could use to analyze that data. And we would try to extract that information, and then, the developers would have a conversation about it and try to plug in different parameters to make it work better.
Okay. Thank you.
Of course. Okay. Yes, sir.
John, this is a pretty cool use case, So
Thank you.
Congratulations. What was the running cost for the client? I know you said the cost was A from your perspective, but what was the running cost? Because it needed to be, you had to tokenize it, you had to do the, kind of the operations, etc.
Yeah, we dug into a lot of the financials when we presented it to them. there were many different variables depending on which APIs they were going to use moving forward. Part of the reason that I didn't speak to the financials here tonight, we were looking at some other paid tools. During the proof of concept, we tried to use things that were very, very inexpensive or even free. Like Serper was, I think it was the tier that we used was a $50 a month cost. So if they were to put it into production and roll it out throughout their team, we would have to have some dedicated APIs that we would pay for. So the financials were much different when we looked at doing it that way than it was for the proof of concept. I would have to review that, and I off the top of my head, I couldn't even speak to it just because it was drastically different from the free tools.
Okay. Second, how long was the proof of concept, you know?
So the proof of concept lasted about, I want to say it was just about 3 weeks. There was a period of time in there that the client was actually our contact, our lead was on vacation. So it took a little bit longer than we wanted it to. But you know, we had about 3 weeks into it.
Cool. Thanks, John.
Sure.
Thanks.
Okay. All right. Well, thank you, everyone. I appreciate it.
Thank you. Thank you. Okay, cool. So now we're finished the two presentations. Thank you again to Carlos and John and Programmers Inc. And so now we move into the closing panel part. And this part we're intending to be more interactive. So we'll just start with some question. And I want to also, of course, introduce Mo Hagigi. He's the Senior Director and Distinguished Engineer at Discover Financial Services. And he recently, actually not too recent now, right? 6 months ago, you moved from London to Chicago. So yeah, so we're still welcoming you. Yeah, you're still in your first year in Chicago. So yeah, so welcome. And then we also have Ron Arunava Majumda. And some of you may recognize him because he and we were running the AI camp too for quite some time. So yeah, so we're just gonna have like a free-flowing type of panel discussion around like agentic AI, and then again, everybody can be a speaker. You can be asking questions and kind of hopping into the conversation as well. So yeah, and but let us kind of figure some things out because there isn't any microphone. So, but I think it should work with this. Is that correct, Jay? Yeah, maybe we can. I think everybody can hear us okay, right, in this room. Okay, cool. So yeah, so I'd like to invite Mo and Rod here. Yes. Cool. Yeah. Ron, sorry, I'm holding that microphone. So yeah, hi guys. But yeah, so it looks like we're going to need to have to kind of share this microphone. This one is actually for the live streaming for the YouTube as well. So yeah, let's see. I think we need another one from Jay, right? What is
for audience to ask
for
questions.
audience too. Oh, okay. So
Okay.
we'll share.
We'll share.
That's fine.
I think
yeah.
I'm loud enough.
Yeah.
Loud enough.
That's true. Okay.
So you guys can hear me.
Yeah.
So
Okay. All right.
okay,
So
I guess you guys are gonna attack me from two ends. Huh?
yeah, that's right. Yes.
Very good.
Yeah.
So
Anybody can attack
two
you.
agents. I'm the single agent
Yeah.
in between.
So, okay, so I'm going to be more of moderating and then asking Ron and Mo. So I'm going to start about this question, right? So both, okay, so Mo and Ron, they're very deeply engaged, like started off with being hands-on software engineers and very deep, especially in Java, for example. So I'm just wondering too, right? With the way agentic AI, is happening now, how does it differ, right? What kind of new changes it has brought on, right? For as it compared with traditional software development? Maybe it's a free-flowing kind of question. What have you found, right? Doing agentic development, what are some of the new things that, yeah, yeah, yeah. Okay, yeah, if you want to.
Oh, okay. Yeah, so it's the next stage of development to me, right?
That's
So a lot of the work that is being done in the front end and the API sort of area right now, we have a bunch of tools, Copilot, Cursor, blah blah blah. There's a plethora of Lovable. We are actually doing an investigation of 8 such tools with some students from Ghana. and some students who are actually in Chicago, UIUC graduate and others. And we'll have a report at the end of the year. So we're doing a very detailed study, and we'll have some rating system. There's no rating system, so we're coming up with one. So all this takes time, but we'll come up with that. So a lot of people are using this agentic frameworks and stuff for that piece of the work. Some people are using. Someone mentioned. I think you guys are using Crew AI, right? NA10 is another very nice framework. They were the first guys who had that whole idea of hierarchical agents, which I love. I love hierarchy. So if you've noticed all my papers that I've written throughout the years, they all involve some sort of a hierarchy. So I love that. So, but anyway, so that's where things are. People are generating a lot of code through the agents and all that. Now, going to the next, and it is again the next step of what we were doing before with no code sort of environments, right? So with no code, we had the drag and drop thing. Now people don't want to move their hands anymore. So okay, let's talk to the system. It'll build everything for us. We don't need to drag and drop. So that's my viewpoint.
Thank you. So Mary didn't actually mention one thing. So we all, the three of us, we have one thing in common. We all used to work at IBM at some point. So at the same time. So yeah. So some of our thoughts and feedback, like whatever we are going to say, it might be a little bit biased based on our background. I'm just saying, could be. You never know. So my perspective, very similar to what Ron said. I look at it from a different perspective. My PhD 12 years ago was agent-based decentralized dynamic data gathering. So agent-based, I had to actually explain agents every time I wanted to present my work, different conferences. Nowadays, it's all about agents. So I can easily say agents. I was like, wow, that's amazing. You did agents 12 years ago. So the traditional way for the AI models, and I still build ML models at home with Raspberry Pis, with NVIDIA, Jetson stuff. So that was very good at kind of rule-based data in not data in intensive, but rule-based and structured sort of kind of models. So that's what the ML models, that traditional ML models are good at. And also when it comes to interoperability with other models, that didn't exist. Right now we are talking about multi-agent systems where agents can actually kind of communicate, they can interact. And that's a fascinating thing, because before, all these models, they only had to go through some sort of API interaction in order to make that sort of bigger scale sort of utilization of machine learning. Nowadays, when you look at LLM and how LLM basically empowered all these models to interact without having to design the APIs and having that sort of kind of meta language sort of in between them, that makes it quite interesting, because at some point we can expect systems that automatically try to discover each other and then collaborate, and then adapt. This didn't exist before. So collaboration had to be done by humans. You had to actually manually write that sort of piece of code that connects them together with all the middleware that we've got, like big hyperscalers and companies wrote. Now we are kind of at a stage that these models can collaborate, they can adapt because of LLM. That's quite fascinating. And then the next step is the optimization. That's the way I look at it. I might be wrong. You might have some feedback saying like, no, you're wrong. But that's the way I look at it. And I think that makes it quite interesting. And at the same time, exciting and a little bit like kind of, scary, because these models can at some point start to kind of, optimize themselves in a way that it becomes like a black box. So for me, coming from financial services, everything needs to be explainable. They need to be, you need to have ways to interpret whatever is happening within that black box. If you are dealing with credit scoring, if you're giving, loan to someone and not someone else, then you've got to have a system in place for regulators to actually see what's happening here. And at the same time, for fraud detection. So when you have systems that are building systems like the iRobot movie 2004, Will Smith, then it becomes a little bit kind of scary. That's the way I look at it. So I don't want to make it longer than this.
Thank you. Thank you. Okay, so I think then, I guess if folks have questions, we can have folks start asking. Wow, so many. Okay, cool. Let me let them. Yeah.
Thank you.
Okay.
At the risk of kind of being a heretic, and I use generative AI a lot. Do you think with the amount of hallucinations and some of the limitations, there'll be a little more realistic viewpoint of what AI can actually is going to take over?
So I'll start with that. Okay. So yes, there is a limitation. So if you so I actually enrolled in a PhD program at IIT. I didn't join in the spring, so that's a different story. We'll see what happens in fall, but that's a whole different story. So I was initially thinking about how we can tackle that problem actually. So the problem is because we're dumping a lot of data into it, and the bigger we grow, actually there is a breaking point. So if you pour more data into it, build bigger models, like now we're up to like 10 billion, we can go to trillion. It's just going to take a lot of resources. But are we going to get out of the three biggest problems to me with LLMs? One is the hallucination that you mentioned. The other is data drift. And the third is model drift. Okay. So the data is constantly changing. The model training cannot keep up with the changes of data. Say I'll give you a very simple example, right? What is the data, what is the weather in Washington, D.C. at this moment? It cannot be trained on that data because the data is not available. Data is only available right now from NWS, right? So you cannot actually train with current data. It is just not possible. Now, even if you ask 7 days back, it can hallucinate, right? So it's a non-deterministic system, and that is exactly what it is. It is a probabilistic system, and we have to live with that. And it is the way the LLMs are, right? So it is ultimately a attention network, which is generating one word at a time. It is predicting one at a time, right? So it can hallucinate. It is part of the problem. And then there's the data drift and the model drift issues, right? So yes, there's a limit. If you keep on increasing, it's not going to work. To me, why I like hierarchical systems, even in agents like N8N. If you look at it, they have a whole network you can create. We are building our own agentic framework, so we'll talk about it in a couple of months, maybe. But anyways, or if you sign an NDA, we can talk about it, or any one of you. So that is the problem, right? So if you think about it, you don't go to a history professor asking uh, things about black hole evaporation, right? So you need different people specialized in different things and access to different types of data to be able to do this, right? So the routing through the agents is the ultimate goal to get to the right answers. And then again, you have to see whether it's hallucinating or not. There are ways of doing that, but RAG is one of the methods, but there's other search mechanisms, right? Yeah, again, hierarchical searches. I love hierarchies, right?
Awesome. I think that's a good answer. So
okay, there you go.
Cool.
Yeah, and
I think there are more questions. Yeah, that's true. Lots of questions. That's cool. Yeah.
In the financial world, how do you find out if the AI is hallucinating? Because as you said, there's a black box problem everywhere.
Financial.
That's a more
Sorry, I didn't hear the first part.
what is the financial?
Yeah, financial world, like credit score, for example. If there is some hallucination on the part of the AI, how do you find that out? Because there's a black box that occurs.
Yeah, it's a finance issue, it's a legal issue, it's an insurance issue.
Yeah.
Hallucinate, you're in trouble, right?
So I can just talk about financial services in general, not about any specific firm. But what I can say is what I'm seeing at the moment in financial services world. Um, Corporations are not trusting AI, and they're not actually utilizing agents the way that the world is actually talking about it. Um, Everything is very experimental, and again, it's because of that sort of black box problem that you don't actually see what's actually happening until you have multiple layers of kind of quality gates to make sure that humans are there to double check every decision that. So for any AI driven decisions, whether it's again for let's say credit scoring, for fraud detection, for regulatory approvals, there are going to be humans involved. So the way regulations basically define that you need to have people checking, double checking, triple checking everything. So I have only seen AI kind of augmenting the work of developers. If you look at it from the technical side, SRE, DevOps, and then go all the way to business marketing and sales. It's only there to augment. It's not to replace people. It's to kind of reshape the sector and then help people to kind of go through those routine tasks kind of in a much more expedited way than before. And I personally don't see that happening anytime soon, that we basically replace humans with AI. It's there to help developers. Like when I look at it from the developer's perspective, a quick example, since you mentioned Java, one of the biggest problems for many insurance, financial services, even in the healthcare industry, they have a lot of programs that are written in Java, and they're quite old and legacy systems. Sometimes they're like big problems out of Log4j or some other libraries that quite common. One of the biggest issues was like you want to always keep your, let's say Java again, going back to that, your Java program up to date. So we still have a lot of developers who would love to write a program in Java 8 rather than the ones who are doing Java 17, for instance. And then refactoring that program requires a lot of other changes in your libraries, in your configurations and dependencies. I have seen companies, again, in my previous job across Europe, that had to go through a year or even longer just to refactor a single application. Nowadays, with tools like Copilot, you can easily, GitHub Copilot, you can easily just say, hey, I've got this piece of code and I did that just like a year ago. I just wanted to see what it's like. So can you write this, client and server socket, program in 5 different versions of Java? And it was fascinating. It did that in such a short amount of time. It took like 2 minutes or so. And just put that aside, that can easily add a month or so to a developer's work with respect to all the dependencies that exist there. And nowadays, developers are utilizing that sort of amazing capabilities. And it's a big deal, by the way. It's like multiple departments working together, making sure that they keep their programs at the same time updated with respect to the program that is being updated. And that is helping developers. It's not going to replace them. It's going to take away that sort of boring routine task of kind of refactoring a program from a previous version to the next version, and then help them to use their time and talent for something better, to innovate, to do something like, to kind of collaborate with other developers to learn even more about the area that they're working in. So I see, at least I can say 25%, like based on all the conversations I'm having with developers, it has increased their speed by 25% minimum. Just using Copilot. Yeah, that's amazing. For instance, I was talking to, and if you look at it from a different perspective, for regulatory approvals, you always have a number of processes, very boring, but again, they're there. You want to make sure all those checkboxes are, looking for vulnerabilities in your code. Nowadays, you can just push your code through some code scanners, and find all the vulnerabilities. It may not be all of them, but it could have easily taken a developer a couple of days to find those, but now it's much faster, so they can actually spend more time to find those deeper ones, or the ones that are kind of dependency related, even though we have amazing softwares for softwares for the past 10 years that they do the job perfectly, but it's still, when it comes to multiple kind of dependency, multi-dependency systems, it's much faster with that. So that's the way I look at it.
Yes. Okay, I'll have 2 answers for you. So first of all, to the financial. So everything is a problem, like I was saying. If it hallucinates, it's a problem. Okay. So whether it's a finance is very acute because you're losing money, right? You don't want to lose $1 million just because someone hallucination. But talking about replacing people, right? People are replacing people. So it is happening today. It has happened already, right? I'll give you a very example. We all come from IBM. When I was leaving IBM, there's no HR anymore. Okay, so there's a HR bot. It was terrible, terrible. It does not answer a single question I was asking. Okay, here's a website. Okay, I've already seen the website. That's why I have a question, right? So yes, totally agree. We are not there, but it is happening. It is a lot of people I know are no longer there in multiple organizations, not just coming from my IBM background. But a lot needs to happen. Okay, how do we solve that? Again, we have to get to a deterministic way of getting the results. Okay, so I'll leave it at that.
I think there's a question too, right?
This question is directed at our guest. Sorry, I stepped out and I didn't catch your name. Mo. Okay. I find it really interesting that you had you went into a PhD about agents before all this big agentic stuff started happening with LLMs, right? Now you were talking about adaptability and collaboration as like important aspects of multi-agent systems. So I kind of assumed that the ability to do that would be important for a singular agent. From your time, in your PhD and as you've worked with these agents, what is your definition of an agent? Right? Every company has a different one, and I would just like to hear yours.
I don't know the exact definition that I used back then, but for me, a piece of code that could actually go through a sequence of tasks and implement them in a way that is adapting to the environment that piece of code is running. So let me give you some background about this. So I had this massive a larger scale sensor networks back then. So it was multiple networks of sensors kind of trying to collaborate and share data, and at the same time come to some sort of conclusion about what's actually happening in this environment. It's called coalition formation. So you break down a task into multiple pieces, and the task that there's those subtasks that are of kind of similar nature, they basically get executed by a number of nodes, let's say, in that network. So I had to design multiple agents, I called them agents back then, agents that could basically run on their own without any sort of intervention. And they adapt to what was happening in that environment with respect to the sort of sensory data that was coming into that node, the amount of resources available for that node, like let's say the battery, amount of battery available for that node, or like how many tasks were already running in terms of the concurrency. So does it have enough, let's say, kind of resources for that extra agent that is coming into that node? And I'm sorry, I'm making it about my PhD. But then I actually had to kind of design that behavior. So I combined game theory with utility algorithms, what's it called, auction-based algorithms. So we've got auctions, which kind of mimics that sort of social behavior, like when we are kind of, fighting for a piece of task, something that we all want to do it. And at the same time, it was selfish using game theory, like a Nash equilibrium. What is my sort of, how can I maximize my own benefits? So it was like to reserve and preserve its own resources, and at the same time, being a kind of an active sort of part of that network, active player. So that was a behavior I designed for my agents. And then I spread them into the network. And those entities or those agents, whatever we call them, they were basically capable of running that sort of executing that behavior in any environment that they got themselves injected into. And then by tasks coming into that environment, they were kind of, trying to find resources that they could actually selfishly put some of those extra tasks to those other nodes, like the neighboring nodes. That's the way I designed my system. And those entities were quite smart from my perspective. Again, 12 years ago when I finished my PhD, so that was actually a big deal from my perspective. Nowadays, if I had all these amazing libraries, or like fire, it would have been like I'm just thinking what could have exactly. So I basically ended up designing a cluster of Raspberry Pis with 132 nodes, and I still have that. A lot of LEDs that shows how many tasks are in there. I still have it. It's amazing. And I just wanted to make sure that I've got the emulation version of whatever I simulated, using Java again. Because I worked for Sun Microsystems, and back then Sun obviously as the inventor of Java It had a lot of inventions, like there was this small sensor board called Sunspot. It was like way before Raspberry Pi even came. It was like 2007. So I basically designed my system for those sunspots, and then I kind of shifted them into Linux-based, boards like Raspberry Pis. Yeah.
Decision system.
Yeah.
What?
Yeah, but very limited collaboration. For what I did, it was like very limited because I didn't need much more than that. It was basically just to make sure that the entire network was capable of preserving itself for a period of time, like 3-4 days, that we had to kind of distribute the sensors across the campus, to make sure that those sensors are able to collect microclimate data. And then actually later at Intel, I kind of simulated the same system for a large network of sensors in Queen Elizabeth Olympic Park in London, and we spread those nodes around, and it was amazing. So it was just like something that I thought back then agents were quite interesting to me. But again, today the way we are looking at agents are completely different. But they must be free to move. They must be they must be memoryless. Kind of not to keep any memory. So those are the sort of principles that I followed when I designed my system. So there are so many books around agents that you can find resources from the 80s. So yeah, I hope I answered your question. But again, sorry, it became so much about my PhD.
I'll just make a couple of comments. So agent, the term AI agent is not new. Okay, so we had been using it in the AI world for some time. Okay, so the thing that comes to my mind is unsupervised. Okay, so they have to be autonomous, unsupervised things, right? If there's any human interaction, that's not an agent, right? So, okay, maybe someone can argue about that too, but to me, that is the definition. Now, today's definition is sort of different. So if you Google, I actually gave a presentation last week on AITP. You can go. The recording didn't work, unfortunately, but I've already published the presentation, so you can go take a look. As for the link, I'll send you the link. But if you Google, right, people are coming up with different definitions. I had a few definitions there, one from Microsoft, one from Google. Everyone is slightly different, right? So to me, it's three things. One is it has to have some AI model interaction inside it, okay? Or else it's not an AI agent, right? So it has to. To me, LLM is just one of those models. It can be a RL agent. It can be a plethora of other agents, right? So one of the programs I'm doing with the car project is we are wrapping around AI agents with ROS, so robot operating system, so ROS2. So those are agents too, right? We're only talking about generation of code or the life cycle. Those are agents. So in fact, the robotic stuff started mentioning agents before the software lifecycle stuff started mentioning agents, right? So we always had agents. Okay. So that's one. Second is it has to have the ability to call some tools from within it, right? Or else it's a problem. Okay. So I'm using MCP. Everyone's moving into MCP now. If you don't know what MCP is, it's Model Context Protocol. That's where things are moving. I just saw a bunch of Docker MCP stuff. I haven't tried it yet. I just saw it like end of last week or something. But see, this is where things are moving. Okay, so they're even Dockerized MCP tools now. The third thing, so people say it's always has to take a decision. Sometimes it's not a decision, it's some action or it's some output, right? So if I'm asking it to generate some statistical information for me, the output is a statistical graph, maybe, okay, or something else, right? It's not always a decision, but it is still an agent in my definition. Yes, yes, it has to, right? So that is your decision controller, basically, right?
Yeah. There are two more we should add to that in the advanced agent AI. One is the reflection part of it. Decision. Reflection to fix the decision to make it correct.
Yeah, and that can be another agent, right?
Yes.
So
And
an agent monitoring the other agent.
right. And then the fifth one, I'm adding to your list because your list is accurate. The fifth one is your database or data, not database. Whether you build it off of RAG or agent RAG or just a database pipeline, that's also essential.
We had a session last week, GenAI Collective session, where we had two presenters talking about this exact thing, and they explained how agent RAG pipeline, and data pipelines work for agent AI. So yes, you're right with those three, but I just wanted to add those two more because that's coming up now. That's going to be the next.
So the RAG thing, to me, can itself be a tool. It's just an MCP thing. You send some information, you get some data back from that RAG, and then you present it back to the factory.
Yep. So thank you.
I'd like to actually just make a note too, because I also wonder too, there's also microservices, which is like big in Java world. So I feel that agent in some sense is like microservices. You can also think of it like that because it's self-contained, right?
We're talking about Java,
Yeah,
so
that's right.
I can't resist
Yeah,
myself.
I know.
I
Okay,
gotta
all right.
talk about Java. I love Java. Okay, I always love Java. I still love Java. Most of my code is still written in Java, no matter how many Python lovers are there in this house. What Java can do, Python cannot. Okay, what Python has done is it has moved into the AI world. Most of the modules are actually written in C, C++, and you're just calling it because try writing a pure Python algorithm, okay? You'll see how slow it is, okay? Because it interpret. I love Java, okay?
Yeah. Yeah, that's right. Yeah. Okay. Yeah. All right. Yeah.
Oh, there you go.
Okay. So yeah.
Search. Very good question,
That's a
actually.
good.
So it goes back to a philosophical answer, actually. So when I'm searching, when I'm personally searching for something, do I exactly know what I'm searching for? Probably not, right? So I'm searching, I'm evaluating all the results, right? If I just simply do a Google search, right? I see 10 of the first links, I'll take a look. Who goes to the next page? No, I didn't see anything. Maybe I'll change my search or something. Right, so, okay, so I'm not exactly sure what the result should be. So from my perspective, it cannot be deterministic, right? So, but results can be deterministic, right? So to me, this thing that all these we were talking about copilots and all this. One of the parameters I'm checking for all these 8 products that I said we're testing, including Copilot, Cursor, Lovable, blah blah blah, is the determinism of these products. So if I cannot determine the code that's getting generated, that has to be determined. Okay. If today I can tell you, if you go and try it out, if you slightly change the prompts or something, it'll give you slightly different code. But your requirements are the same. It should give you the same code, or else it's a problem because now you don't know which one is the right code to go on with. So it's not a problem when you're generating for the first time. It is a problem when you're generating for the second, third, fourth times because you're adding some small features into it. That is where the problem is. And that is something we are trying to fix.
I just look at it from the reinforcement learning perspective. It's the same thing because it needs to be memoryless, and the fact that every time you are basically expecting something different, and going back to that award model, like where what's going to happen. So search is exactly the same, but again, we've got, like, if you look at Google page ranking, there's one algorithm that side. Yeah, so many other algorithms that are getting like to exactly fuzzy logic. So that's why it's not deterministic for sure. But one important point that Mary mentioned about microservices, and I think where we are today in terms of machine learning, evolution, it's got to do a lot with software architecture as well, and how we went from monolithic applications into microservices. Because breaking down your code into multiple pieces with proper functions, that's exactly what microservices gave us, that sort of architecture. And because of that, we started thinking about how can we actually automate each one of these pieces. Like, if you look at the word of, since you love Java and I love Java too, OSGI and what we did back then, and then kind of breaking down the code. When you look at cloud computing today and how ML is actually kind of helping cloud and cloud helping ML, it's just because of that microservices architecture that 5 years ago many people were actually quite against it, if you remember. And that orchestration of microservices with Kubernetes, for instance, that actually helped a lot with kind of finding the errors, making sure that you're basically evolving different pieces of the code on their own timeline, having different teams dedicated to different parts, and just like change one thing without breaking down the entire system. Like that. The quick example that I always use is the online store. You can have your billing and catalog services completely running on different clouds, and it's still they all work together. So MCP is, I think, is that next bit, because before it was all about APIs, and now with MCP, we've got this.
So go on. Okay. So to me, I know there's a question in the back. Okay, so someone please go to the back after this. Okay, but to me, we are building up in layers, right? We have always been building up software in layers, right? I don't think about interrupts in a keyboard when I'm typing and writing code, right? Or writing a document, right? If I had to worry about trapping those interrupts to be able to say, okay, on the screen, okay, I pressed A, now I have to put 8 pixels in a particular manner to make A, I wouldn't have been able to do anything on the screen, right? So it is always built in layers. Now the layering is, to me, so you have the base systems, then you have these automation systems, and everything needs to be microservices because that's the world we live in. On top of it, we have agentic frameworks. How do we deploy those agentic frameworks? Again, we need microservices. We're deploying everything on Kubernetes. So all that is built in layers, and that is the orchestration that we're doing at the very top, right? So the deployment orchestration is very different than your process orchestration, things like that. And that is exactly where we need to get to, right? So uh, everyone's talking about like, oh, I can build this really quick and stuff. Okay, quick and dirty was always there. Uh, but can we build an end-to-end system for, say, a credit card system or something, right? Airline system, a critical system, end-to-end, using these bots? No, we can't, right? So it involves a lot of things. Certain things can be automated. We should take advantage of that and build it quicker.
Very good.
Thank you.
Okay, I guess
Really,
let's have
really
one
enjoying
last
this.
question, but we can still stay too because it's getting late. Let's have the formal.
No, but she's waiting for a long time.
Yeah, sorry. Go ahead.
Really enjoying this conversation. I have two very different questions on the topic of making it deterministic, right? Like how do we make the system deterministic if there can be multiple right answers to the same question?
Let's sign an NDA. I'm working on it. Seriously.
Great.
Yeah.
Okay. The second question is a little bit more philosophical. I think on the topic of, how I've been working in the AI ML space for the last 5 years, and I think most of the applications that I'm seeing with the Gen AI is the efficiency gains. Like you're making people more productive, companies more productive, you're doing workflow automations, and at the end, you're looking at time saving so that you could do something more innovative with your time. But then with AI now, I think more and more people are relying on innovation, creativity, emotional intelligence is also coming from these models. Like you're having like intimate discussions with these models instead of humans. Where do you see?
There's this robot, right? People are marrying this robot in Japan, or so I went to this presentation, and it was fascinating. That was at IIT Kent College of Law, actually, a few weeks back or last month, something like that. So I forgot the name of the character, but people are getting emotional. They're marrying. They're spending like tens of thousands of dollars, right? And then yeah.
But I think it was a recent article last week or this week actually, which was like AI, like we had a breakthrough even on the emotional intelligence test, and it like beat a human on that one, which is like almost you're saying like it's not even only technical or like a specific task that it's good at. It can be good at on a different task, right? But the real question is here is what do you think we will be doing with that time that we'll get saved by, like what would we do with all these efficiency gains once we get to that stage? I don't know if you have a view on that.
Person, right? So
Yeah, like
to me, I'll say, okay, this code can be automated. Let's write the next code, right? So that's me. Or I'll do something else. Read a. There's a million things to do. There's a the Webb telescope is creating so much information every day that I mean I can't keep up with it. So if I have time, I'll read up on that a little more. But it depends on the individual, right?
That's all good question. Oh, do we have one more question?
Yes,
Okay, all right. Last question, official question. Then we can still hang out too.
Thank you for the panel. It's been really interesting. Just I look at AI agents or any agents in particular as an ecosystem. It's just the way we trigger it, and it has lot knowledge bases and a lot more. But if you just take a step back and look at it from a bird's eye view, I feel like there are a lot more simpler solutions that can be used rather than AI agents or any kind of LLM or any kind of RL or any neural network that can be
Depending
used.
upon what it is, right?
Exactly.
So that's what I'm saying. So not everything can be solved with
Exactly.
agents. So use the right tool to solve
for
the right
the right
problem,
job.
right? So
Yep.
now if you're asking weather about DC, it's not going to be able to answer that. It's simply that's a very black and white question, right?
Right.
But a lot of these things are not as black and white. They're gray, but there are multiple ways to skin the cat, right? It's not all AI agents, but
Exactly.
AI agent has to be in the mix to solve the problem, right? So whatever it is good at, use the AI agent. That gets us into the same discussion about process engineering, right? So we had very good process engineering over a period of time. A lot of people have automated a lot of things. Don't just disregard that. Add AI to the mix for what it cannot do, right?
Right.
And then you have a solution. If you say, okay, now we're in the world of agents, let's replace it with agents. Well, it's a problem, right?
It is true. I agree. Use the right tool for the right job. I think that's the way to go. So okay. Well, want to thank you again because it's getting late and appreciate again Ron and Mo. Thank you very much. And I think we can still hang out in here and talk too, but then it's getting late, so we need to end this. So thank you again, and please come to more of our meetups. Yeah. Thank you. Thank you. Thank you.